Hey there. So I checked to see kind of what it showed versus what I showed. Yeah, and I would do this problem fairly differently from what they gave here in the detailed solution. In the detailed solution, so just to go through it real quick to explain kind of what you're seeing there. It, there's like you need to remember like a lot of the chapter on logarithms that we covered last quarter in 141. So to get from here to here, we would go if I have x equals e to the negative 2t. If I just rewrote this in log form, you get this expression right here or equation right here. People have a hard time writing that in log form, so let me show it with a step just to kind of remind you why that works. Remember, when you're solving for an exponent, you can log both sides of the equation, and you do that because it allows you to bring the exponent down front. So then we would have ln of x equals negative 2t times ln of e, and remember that ln of e equals 1, so that would drop out, and then they're just dividing the negative 2 over, and that's how they're getting that expression right there to equal t. Once they do that, and remember our goal here is to manipulate these two equations to eliminate the parameter of t, so we're trying to substitute the t out, which we now have t in terms of x, so I can plug that in for the t in this equation, which is what they did right there. And yep, those double negatives just canceled each other, and now we have this. For here, what they're doing is there's that property of exponents where we have, if we have x raised to the a raised to the b, that's the same as x to the ab. So if we had x squared cubed, it would be x to the sixth because we multiply when we raise to a power. So down here what they're doing is they have something in this form right there, and then they're factoring out that 1/2 and writing it in this form. So they're just kind of giving it a little bit different look. And the reason they're doing that is because this is one of those properties from last quarter as well. If you have e to the ln of x, that equals x. It's the or the natural log version of if we had base b raised to the log base b of x. Because these are inverse functions to each other, log base b of x equals some exponent, and then b raised to that exponent gets you right back to the x. So to get from here to there, that's how they're doing that, is using this property of logs. And then that 1/2 they're just rewriting as square root. I don't know why they put the 2 in the index, but they did. Usually we just write that as a plain square root. So that's one way of doing that. I would probably not do that. I would probably do something closer to this. And their way isn't wrong. It's just if I can see an easier way, I usually try to do things the easier way. So here are our two equations. And I'm going to need to I'm still going to need to do a substitution, right? And to eliminate t, I have to get something where I have x or y in terms of something that I can substitute out for the t. So the thing that kind of jumps out at me is this one is e to the negative t, and here I have e to the negative 2t, and that same property that I just showed, where if you have two things multiplying, you can write that as raised to a power. So let me show you what I mean by that. E to the negative t squared, 2 times negative t is still negative 2t. I'm just giving it a little bit different look. And what that does is it lets me get an expression for e to the negative t pretty easily. So from here, let me get e to the negative t by itself, because that's what I'm going to substitute right there. So now I have square root of the square would just leave me e to the negative t. So that's what I'm trying to do, is isolate. They isolated t. I'm isolating e to the negative t instead because it looks easier. And now I can just put this right there, and I got y equals 2 root x. So to me, that was the easier way to solve that than to drag out all those properties of logarithms. And even with this, I tried a couple of versions of it before I made the video, and I have versions where if I substitute the other direction, I get the same thing, but it's a little bit harder math. that's the easiest math that I could come up with for it. But like I said, I saw 3 different ways to do it just using these substitutions, and then they have a fourth one over here. So there's lots of right ways to do it, but there's the easiest one that I could think to show you.